MAT1033 Final Exam Review Question 60. Now this problem is a little more recent than some of the others. This was from Chapter 9, and we're supposed to subtract. We have 3 times the square root of 128, and we're going to subtract 3 times the square root of 50. Well, at first glance we would think, well, we can't subtract those because they don't have the same radical part, but if we take a closer look at the radicands, we notice that 128 and 50, they may contain some perfect square factors. So let's try this. Let's do the tree on 128. So how many times would 2 go in there? 64, and look, there's a perfect square right there. So really this first value is 3 times the square root of 64 times the square root of 2, or 3 times 8 times the square root of 2. So really this is 24 square root of 2. Well, let's see if the same kind of thing happens to the second one. Okay, this is 3 times square root of 50, and if I divide by 2, I end up with 25 times 2. Well, there again, look, perfect square. So we've got minus 3 times the square root of 25 times the square root of 2, and then minus 3 times 5 times the square root of 2, minus 15 square root of 2, factoring out the square root of 2, and combining those values, 24 minus 15, we end up with 9 square root of 2 as the difference. So we could add those after all. MAT1033 Final Exam Review Question 61. We are to add these expressions. These are radical expressions. Square root of 3x plus 8 times the square root of 27x, and then plus 7 times the square root of 108x. We first look at this and think, oh, we can't put those together because they don't have the same radical part. Also, you need to make sure you realize this is 1 times the square root of 3x. Okay, let's run down through here and see if we can simplify. 3x, there's no perfect square factors. 27x, 27 has a 9 in it, so that'd be 9 times 3 times x, perfect square of 9. And then 108, we're not really sure of, so let's try 2 times 54 times x, and then 2 times, well, 54's got a 9 in it, 9 times 6 times x. So we've got 2 times 9 times 6 doesn't have a perfect square, but it is 2 times 3 times x. So really we have a 9, and the 2 2's would make a 4. So we've got quite a bit of work to do here. 1 times the square root of 3x, that stays the same, no perfect square factors, plus, now this would be 8 times the square root of 9, which is 3, and then of course the 3x would remain as the radicand. That's 24 square root of 3x. Now those are very much alike in that they have the same radicand and the same square root symbol there. So this would be 7 times the square root of 9, which is 3, times the square root of 4, which is 2, times, and then the 3x would stay there as the radicand. So this would be plus 7 times 6, which is 42 square root of 3x. Factoring out that square root of 3x, combining these values, 1, 24, and 42, we end up with 67 square root of 3x.